here. Backing up with this camera and recording with the Zoom camera. Okay. Yeah, this isn't right. I'm not on the right board. Busy getting the camera set up and a backup camera. Okay. Now, messing around with my backup camera, sorry. Shouldn't have to use a backup camera. Zoom ought to be working, but something is screwed up, so I'm going to have a backup, which will moderately interrupt things from time to time. See how this works. I can't get that camera to quite go to the bottom of the board, so I'm going to have to remember that. Okay, sorry. This is a repeat of what we did in class when Zoom recording didn't work well, maybe due to slowness of my ISP, but maybe not. We don't know what's going on. Okay, talked about equations of straight lines. General form is y equals mx plus b, called the slope-intercept form, where m is the slope and b is the y-intercept, something everybody should be familiar with, at least should have seen, so this might refresh your memory. Okay. Now, we call that the standard slope-intercept form, at least that's what I call it. If you have a set of xy coordinate axes and a line, straight line, it's going to have a slope. The slope is going to be determined by the rise and the run of a fundamental triangle through any 2 points on the line. And it's the same for every 2 points. Doesn't matter which 2 points you use, the slope is always going to be the same. And you have a y-intercept, which is the coordinate in the y-axis where the graph crosses the y-axis. Okay, the slope of any fundamental triangle between 2 points is m. That's your slope. Okay, so slope of this triangle is m. So now, for example, if we have a triangle, a straight line through the point x1, y1 and the point x2, y2, the run, as we've seen much earlier, is x2 minus x1. Subtract the x coordinate where it's ending up. Well, subtract the x coordinate where it starts from the x coordinate where it ends up, and that's your run. The rise is y2 minus y1. Similar, y coordinate where it starts, subtracted from the y coordinate where you end. Now, I always say that when you do the fundamental triangle, you indicate your positive direction to make sure that everything is consistent. So I put arrows on the hypotenuse, arrows on the 2 legs of the triangle, and the arrow runs us from this point to this point. The arrow on the hypotenuse runs us from here to here. The arrows on the legs run us from the same point, same initial point, to the same final point. So 2 paths to take us from this point to this point. Then we do the y2 minus y1 over x2 minus x1, which represents the rise divided by the run, and that's what the slope is. Slope is not a formula. It's not y2 minus y1 over x2 minus x1. It's rise divided by run, and that's why it's y2 minus y1 over x2 minus x1. And I, for some reason, it's been a couple of days since the whole meltdown of the technology. Oh yeah, we'll get to that. Okay, now, so if we know x1, y1, and x2, y2, we get the equation that y minus y1 over x minus x1, which is the rise divided by the run, is equal to the slope. And here's another expression for the slope. Okay, take this point x1, y1. We could as well have taken x2, y2, but we'll use x1, y1. And any point xy on the graph. Okay, if xy is on the graph, is on the line, then slope has to be the same as the slope between x1, y1 and x2, y2, because these are 2 points on the line. Okay, so the rise and the run are, as you see, y minus y1, x minus x1, where x and y are variable quantities. Remember, this could represent any point at all on the graph. So that the slope expressed in terms of x1, y1, and the arbitrary point xy is y minus y1 over x minus x1. We set these two expressions for the slope, this one equal to this one, because the slope has to be the same between any 2 points. And here we have an equation. And then we multiply both sides by x minus x1. And that's going to give us y minus y1. Well, multiplied by x minus x1. The x minus x1 divides out. We get y minus y1 equals y2 minus y1 over x2 minus x1 times x minus x1. And I'm not sure that this backup camera is picking that up, so there it is. Okay. This is the 2-point form of the equation of a straight line. You can memorize that equation, or you can understand where it comes from so that in case you forget it, you can always rederive it. Now, not everybody's going to want to do that. Not everybody's going to have the set of perceptions that allows them to easily do it, but some might, and this is the way it comes about. So there's a reason for it. Okay. Now, I think that the next thing I did was this. So let's do it. Okay, so here we have a line, just a straight line that goes through the point, well, it goes through the x-axis where x equals a. So you have the point A, 0. It goes through the y-axis where y equals b. That's the point 0, b. If you've got an x and a y-intercept, now sometimes a line can go through the origin, and then you don't have two intercepts. But for any other type of line, you will have two intercepts, and we can find the equation of the line based on these intercepts. Well, slope of the line is what? The slope is the rise divided by the run of any fundamental triangle, but I went ahead and chose the easiest one, the fundamental triangle that goes through the points, whose hypotenuse goes from the point 0b to the point A0. And this triangle has a rise of negative b. You can see that here's the y coordinate is b, down here the y coordinate is 0. So you have a change in y of negative b, that's your rise. And a run of, well, you're running right along the x-axis from 0 to a. The run is just going to be a. Now, we can formally do that. We can do the rise, which is going to be 0 minus b. So, and that's up at the top of the board where you might not be able to see it. I'll kind of lower the board here in a minute. One camera can see it, the other might not. But anyhow, the rise will be y coordinate minus y coordinate, 0 minus b, if we're going along the triangle in this direction. And the run will be a minus 0. So we see that, rise over run 0 minus b over a minus 0. And of course, that's just negative b over a. There's your slope. So slope is negative b over a, and the y-intercept is b. So we can write the equation of the line. Now, I think I never did write the equation of the line, but the equation is y equals mx plus b. And that then equals, since m is negative b over a times x plus b. A more specific example. Here's a line with intercept 0, 6 and 4, 0. Okay. The slope is -3/2. And it appears that I didn't finish this. That wasn't necessarily an oversight. That's just, I chose to move on to another example. But if we apply the same thing to this triangle, we see rise is -6, run is 4. Slope is -6/4, rise divided by run, which reduces to -3/2. So the equation is y equals mx plus b. So y equals slope is -3/2. And b is the y-intercept, which is 6. There's the equation. Now we should plug 0, 6 in. Okay, for 0, 6, x would be 0 and y should be 6. Well, if x is 0, then this term is 0. You get 6 here and y is 6. Similarly, if you plug 4 in for x and 0 for y, you should get 0 here when you get 4 here. Well, you put 4 here, -3/2 of 4 is -6. Add that to 6, you get 0. So it checks out. I didn't write out the check. I did write out the check on this next example. Straight line through 2, 3, and 8, -1. Now things get a little bunched up down here. And we do have the problem of the backup camera not being able to see this. It's pretty risky. Let's see if I can balance this on the. As long as I don't touch anything. And then if something does happen, hopefully my reflexes will handle it. We'll see. Okay. The whole place might get wrecked here if something goes wrong. Okay, so straight line through these points. Now there's a mistake here. Okay, and I actually made the mistake. I wasn't just pretending, but it works out because now we can see what happens if you do make a mistake and you happen to check your answer. You can go back and find your mistake. So I'm not going to say where the mistake is, but we have the point 2, 3 and the point 8, -1. We have the straight line through those points. But we make a fundamental triangle for those 2 points. The rise is -3, the run is 6. So the slope is rise divided by run, -3/6, which is -1/2. Okay. Now let's do another fundamental triangle using the point 2, 3 and some point x, y that could be any point on the graph. Slope of this fundamental triangle, well, the rise is 3 minus y and 2 minus x. So rise overruns 3 minus y divided by 2 minus x. So the equation's 3 minus y over 2 minus x equals -1/2. But we can solve that for our y coordinate. We can solve it for y because we want to try to put it in slope-intercept form. Okay, well, nothing fell yet, so let's just get this off of here. And I'm going to manage these boards just a little bit. Because I'm going to want the back of this board. And I'm also going to want the back of this board. And we'll come back to those after we finish this example. Okay, so continuing the example we started with, finding the equation of the line 2, 3, and 8, -1. And we probably ought to have a comma after that 8. Definitely ought to have a comma after that 8. Okay. I'm going to go through all the details of solving this for y without resorting to any superstition or any kind of foolishness. Okay. You see what I mean when we do it. So the equation is 3 minus y over 2 minus x equals -1/2. We're going to solve that for y. What do we do? Well, we have a denominator here. Also have a denominator here. Normally, I would multiply by the product of these two denominators. But for now, I'm just going to multiply by the 2 minus x. Because actually, in this case, that's kind of what we want to do. Okay, so, well, multiply both sides by 2 minus x. Now, these are fractionals. They're rational expressions. They're fractional in nature. So we want to be careful about the rules of fractions because people are typically not real good with rules, with operations involving fractions because, and I always say, we teach people how to do fractions in 5th and 6th grade, and then we put calculators in their hands, and they never have to do one again. So by the time they get here, they can't do them. Hopefully you're an exception, and there certainly are exceptions. Okay, so when I multiply by 2 minus x, I multiply by 2 minus x over 1. Just keep the numerator and denominator straight because people don't always do that. They mix up numerators and denominators. And then, of course, on this side, which is negative 1/2, I have to multiply by the same thing, 2 minus x over 1. Then we multiply the fractions. Okay, well, we multiply the numerators and we multiply the denominators. 2 minus x times 1 is just 2 minus x. 2 times 1 is 2. There are denominators. 1 times 2 minus x is 2 minus x. And 3 minus y times 2 minus x is 3 minus y times 2 minus x. So right there is our equation. Now we can rearrange the equation. Well, we can rearrange this expression as 3 minus y over 1 times 2 minus x over 2 minus x. If you don't see why, or if you don't believe me, just see. If I multiply the numerators, do I get this numerator? Yeah. If I multiply the denominators, do I get this denominator? Yeah. Okay, so this represents the same thing this does and the same thing this does. So there we have it. Now, 2 minus x divided by 2 minus x, when you divide something by itself, unless it's 0, you're going to get 1. 0 divided by 0 is undefined. So 3 minus y over 1 times 1 on this side. On this side, I want to go ahead and distribute the division by 2. Negative 2 over 2 is negative 1. X over 2 is x over 2. Now, one reason I'm doing this is because people don't cancel right. Okay? If you give this to a beginning pre-calculus class, in my experience, 95% of them are going to cross out these 2's and say the answer is negative x. Okay? That's so totally wrong that it doesn't even come up to the level of something that deserves a comment, except that if you understand algebra, you know how bad that is. Okay? And I'm not saying that people are bad. I'm saying our educational system's bad because it doesn't teach people why the rules work. Just gives them rules and they forget them and do it wrong. Okay? And it's a very natural outcome. I don't know what to do to fix it. And if I did, nobody would listen to me, but there it is. Okay, so I'm not putting you down to say that most people that come into this class can't do fractions and can't be trusted to cancel. Okay, just, I mean, if you know the rules for cancellation, yeah, that cancels that, and everything happens very quickly. Here's how we do it using secure rules. Okay, so we're down to this point, and then this divided by this is 1, so here we are. And now 3 minus y over 1 is 3 minus y, and 3 minus y times 1 is 3 minus y. So here's 3 minus y, which equals x over 2 minus 1. Subtract 3 from both sides. And finally, we end up with negative y equals x over 2 minus 4, and there's our equation. Now remember, I told you there was an error. You might have spotted it. And it was just a careless error. I wrote something down that just wasn't right and followed it through. Now, all the steps here, I think, are correct. But with that one error, the equation's not going to work. You won't know the equation doesn't work unless you check it. So how do you check this equation? You plug in 2 for x and 3 for y. So we plug in 2 for x and 3 for y. And again, we're down to the low board I'm living dangerously here. I can't do it with this board. It's a whole board. I'll just say, if you plug this in, you get y equals negative x over 2 plus 4. Y is supposed to be 3 if x is 2. Well, negative 2 over 2 is negative 1, and add that to 4, and you get 3, which is what you're supposed to get with 0.23. So right now, I'm feeling pretty good about this solution. However, when I plugged negative 1 in, it didn't work. Okay. Now, again, on the Zoom video, you're going to be able to see this. On the auxiliary video, you're not, because it's down too low and I can't raise this board. But plugging in 8 for x gives me negative 8 over 2, which is negative 4. Add that to 4, I'm getting 0. But the y is supposed to be negative 1, not 0. So when I plug into this, I get negative 1 equals 0, which is false, which means my solution doesn't fit that second point. Okay, so there's an error. Now, how do we find it? Well, if you go back to the original and want to work this through yourself, which would be a bad idea, I said the rise was negative 3, but it's negative 4. And that's very clear if you just look at the points. I didn't look at the points. I must have had a 3 out of my peripheral vision or something and wrote it down carelessly. Well, if I can do that, you can do that, which is why you always check your answers. Unchecked answers that are wrong, okay? Checked answers that are wrong get a substantial amount of partial credit if your basic steps were okay. So you want to remember that. Okay, well, there we have this. Now, one more example. Now, in class, of course, I wrote this out as we went, but you're given a line segment here, a line segment here, a line segment here, and the coordinates of the endpoints of each line segment. So negative 6, negative 5 here, negative 2, negative 1 here, negative 2, 2, 2, 2, 2, 5, 5, negative 2. Now, this one ends when x equals negative 2, and this one picks it up right past x equals negative 2. Negative 2, the x value negative 2 corresponds to a point on this segment. It does not correspond to a point on this segment because this is open here. So this starts right after x equals negative 2. And similarly, we have a closed dot here where x equals 2 and an open dot up here where x equals 2. So this describes a function that's defined all the way from negative 6 to 5, on the whole x interval, negative 6 to 5. How do we express this function? Well, it's a piecewise defined function, and it's piecewise linear. All these are straight lines. They can have piecewise quadratic functions, maybe a piecewise function that's exponential, one interval and quadratic on another, whatever. I see a smudge here, so it's okay. Make sure that can hopefully be read. Okay, so first thing we want to do is get an equation for this line, for line through these points. That line starts here, stops here, doesn't go all the way through the points. It's not a whole line, it's a line segment, but it's still going to have the same equation as the whole line. And that's probably not an issue for most people, so wanted to mention. Okay, slope of this line segment is easily found, rise divided by run, plus 4 divided by plus 4. From negative 6 to negative 2 is 4. From negative 5 up to negative 1 is 4. If you do the fundamental triangle and all that stuff, you find that the slope is 4 over 4, which is 1. So y minus y1 over x minus x1 should equal the slope. Okay, because this would be the slope between x1, y1, and any point xy that happens to be on the line. y1, x1 and y1 are -6 and -5, right there they are. So just plug those in. We get y plus 5 over x plus 6 equals 1, because negative of negative, negative of negative, both positive. And then I didn't go through all the details, but we multiply both sides by x plus 6. The x plus 6 we multiply on this side ends up in the numerator, and you can rearrange the things so you have x plus 6 divided by x plus 6, in which case you get 1 and the x plus 6's go away. So you get y plus 5 on this side, you get x plus 6 on this side, and you subtract 5 from both sides. You get y equals x plus 1, and then you check. I didn't go through the check, but you have to know that you check. Okay, now let's see. I think that last step, y equals x plus 1, in the instruction to check, right there on the backup video. Okay, well, there it is. That's the equation of this segment, and it applies for x greater than or equal to -6 and less than or equal to -2. We'll come back to that. This line, well, the y-coordinate is 2 at every point. So this is an example of a horizontal line. The horizontal line, y equals 2. And that horizontal line, well, we take the part of that horizontal line where x is greater than -2, not equal to -2, but greater than, and less than or equal to 2. And that's this segment. Here, we do the usual. We have the 2 points. We calculate the slope. Rise is -2 minus 5. Run is 5 minus 2. So the slope is this, which gives you -7/3. Then, if you assume that xy is an arbitrary point on the segment, the slope from -5, -2 to xy has to be equal to -7/3. And the slope from 5, -2 to a point xy is y minus 5 over x minus 2. The y coordinates, the x coordinates, the 2 points. Then we simplify this, and just a little algebra here. We have y minus 5 equals -7/3 of the quantity x minus 2. Now we want to multiply through here, and we could get -7/3 x and then plus 14/3. We'd be dealing with a fraction. Okay, we don't want to deal with fractions if we can help it. It's usually simpler to deal with whole numbers, integers. So we multiply both sides of this equation by 3. That clears out the denominator. On this side, of course, we get 3 times the quantity y minus 5. On this side, we get 3 times -7/3 times x minus 2. And 3 times -7/3, well, that's 3 over 1 times -7 over 3, which could also be written as 3 over 3 times -7 over 1, similar to what I did before. And then the 3 over 3 gives you 1, and all the 1s are there, and you end up with -7. Now that's something you got to write out. Think about the way I did it. It is legal to cancel here, but again, I don't want to. I really don't want to see wrong cancellation. Better off going through all the steps. Okay, so anyhow, the equation becomes this, and then we can distribute this -7 times through the x minus 2 multiplication by the -7, get -7x plus 14, and 3y minus 15 is going to equal that. And now we're down to a simple linear equation. We add 15 to both sides. 14 and 15 is 29. And we just end up with 3y over here. We want to solve for y, so we have to divide both sides by 3. Well, here we've got it. And then we distribute this division, and division distributes over addition because division is nothing but multiplication by a reciprocal. So 3 goes into -7, gives you -7/3. So we have -7/3 x, and then 3 goes into 29, gives us 29/3, and there's our equation. Now again, we can check it. If we plug in 2 for x and 5 for y, and I believe this camera's picking up everything. Yeah, we plug in 2 for x and 5 for y. Well, x is 2, so we get 14 thirds. Add that to 29 thirds. Negative 14 plus 29 is 15. We get 15 thirds, which is 5. 5, yeah, okay. And that is the y coordinate we get for this point, so that works. If you plug in 5, negative 2, then you're going to get negative 4, positive 14 thirds. And 14 and 29 gives you I'm sorry, plugged the wrong number there. Okay, wasn't making sense. Plug in 5 for x. You get negative 35 over 3 and 29 over 3. Well, negative 35 and 29 is negative 6. Negative 6 over 3 is 2, negative 2. And that's exactly what y ought to be. Okay. So finally, what's the equation corresponding to this graph? Well, the equation is y equals x plus 1 here, 2 here, and negative 7 thirds x plus 29 thirds here. And I think both cameras are picking all this up, so I think we're good. Okay. Now, we got to specify, though, for what values of x each of these applies. Well, clearly the x plus 1, that's this one, applies for x from negative 6 to negative 2, including negative 6, because that's a closed dot, and the negative 2, because that's a closed dot. So we say x plus 1, negative 6 less or equal to x less or equal to 2. So that domain, this is what it is, or that part of the domain. Okay. Now, in the part of the domain between negative 2 and 2, including 2, but not negative 2, we have y equals 2. So we say that applies when the interval negative 2 less than x less or equal to 2. And then finally, we have this function, which applies from 2 to 5, x equals 2 to 5, but not at x equals 2 because of the open dot. Okay, so now every x value from negative 6 to 5 is included in the domain of the piecewise function. From negative 6 all the way through negative 2, including negative 6 and negative 2, and then picking up right after negative 2, going up to 2, and picking up right after this 2 and going up to 5. All x values. This gives you a rule that allows you to determine the value of this function for any value of x.